Swayam Prabha. Digital India. Educated India.
Hello, hope you are enjoying the theory classes and the laboratory sessions. So today we'll look at a new product, which is the CD player. A CD player, which may not be very common nowadays because people have moved away from the CD player and started with more digital players. But CD player is one of the products which has got a lot of design features. So if you look at a CD player, you will see very small components and very intricate assemblies, which actually provides you a very nice view of how a product can be designed. A very compact product can be designed with multiple functionalities. So this product, learning this product, though the product is not very common nowadays, you will see that it has got many things which a designer has to learn. A designer will be able to understand how people design such complex products. And there are many such complex products in the market, not exactly CD player, but most of them will actually take these design concepts in developing new electronic products. So what we'll be doing here is, again, as in the other cases, other exercises, I will go through the complete dissection of the product and then identify all the small parts and small assemblies and many complex structures inside. And then finally, we'll look at the product from the design point of view and then see what is the portfolio architecture that we can actually think for this product. So in the product architecture, we mentioned that there are two things which we need to understand when it comes to the architecture. One is the architecture of the product itself, and then the portfolio architecture. So how many members should be there in the family of the product, and then that actually depends on many things like the market requirement, customer segments, and customer preferences, etc. So since we don't have any market survey at this stage, so you have to make some assumptions about the market variations, market segments, and the customer preferences. So based on that, you will try to create a portfolio architecture for this product. So we'll go through the product dissection as in the previous cases, but at the end of this, you need to create a portfolio architecture also by looking at the methods that we discussed for portfolio architecture, and then identify how many products should be there, and in that product what way the sub assemblies to be made or the modules to be made in order to get a different architecture for the product. So that is what we are going to see in this class. Okay, so to understand the functioning of the product and identify all the parts, prepare the parts list, and for some identified needs, prepare the need metric chart. Okay, so that will be interesting here because you prepare the needs for the customers and then prepare a need metric chart, and then prepare the portfolio architecture based on assumptions for the distribution of customer requirements. So once you have some customer needs identified, you try to identify what will be the customer requirements and the variation in the customer requirements for that particular need, and that will give you some idea about what is the way it is distributed and what are the different segments of customer that you will be having, and based on that you can prepare the portfolio architecture. Again, we have seen few examples of portfolio architecture in the theory class, so use those principles and then try to prepare the portfolio architecture. Okay, so this is the drive. Okay, it's a DVD drive, and this is manufactured by Samsung, and the model is CTO Edge. Okay, so CD or DVD, the internal structure almost remains the same except for the reading and other matters, but the design or the mechanical design will almost the same. Okay, so the major functions are basically to read data, write data, spin the CD, secure and lock the CD. So you'll see that there are multiple functions to be achieved in the product in order to basically data storage. So you can actually say store and read data is primary function. So it has to store data and then retrieve data from the disk. So that is the main purpose. And to do that, you need to read, write, and then spin the CD in order to do the reading, and then you need to secure and log the CD. So these are some of the sub functions that you need to do. So as the TA explains different components and sub-assemblies, you will be able to understand, okay, what is the role of that particular part or the sub-assembly in providing the main function to the product. Okay, so the procedure again almost the same, but what we need to do is basically the customer requirements, identify the customer requirements, requirement statistics, and then design the portfolio architecture. That is going to be the difference in this case compared to the other exercises. So the primary part, the first part remains almost the same, that you go through the parts and then assemblies and then structure and things like that. But at the end of this exercise, go for a customer requirement statistics. So basically make some assumptions about the customer requirements and the distribution, and then prepare the portfolio architecture based on that. So this is what is expected, and the report will be the format again almost the same in the previous cases also. You'll be doing the product details and product history, and then you'll be going through the parts list, then assembly chart, and then finally the portfolio architecture. So complete this portfolio architecture and then submit your reports. So the TA will be explaining to you in detail about the product and how the product functions and what are the internal parts and how each part is contributing to the main function of the product. Okay, thank you.
Welcome. Today we'll be looking at a DVD drive and a old school film camera. So let us start with the DVD drive first. Now let us look at the interface. So we have, this is what is called as an IDE interface. This preceded SATA that is used today, and this is the power input, and then you have other pins basically. So this basically should basically slide into the computer case, which means you cannot have any projections on the outside. So the projected area or the projection of this CD drive should be should be in the shape of rectangle. So that is why you will find all the fasteners here are recessed. You will find all the fasteners that the device uses are recessed. That's why they are kept a little bit below the surface, primarily because you do not want any of the screws sticking out of the device. So you do not want, so you want all the fasteners that are holding the device together to be recessed, primarily because you don't want any of them sticking out. Otherwise, if they stick out, they'll basically interfere during assembly. So that's why they are basically kept below the surface of the drive. So to speed up, I've removed 3 of the 4 fasteners. Let me remove the 4th fastener. Now that I've removed, now I can take it apart, but before that we have to remove the front case of the device. So this is held in place by a snap fit. So how we remove snap fit is basically we take a flat end screwdriver and then we basically depress the snap to release it. So once it is done, it is released. There are no fasteners holding this in place. So you have these snaps here. Basically, you can see they basically flex. And once I remove all 4 fasteners, I can basically remove the lower case. So now that we have removed all 4 screws, we can proceed to dismantle the outer casing. You can see at the bottom casing there is a small rubber pad. This is called as a thermally conductive medium. So basically this contacts the processor and transfers the heat to the entire case. So the entire case now functions as a heat sink. So whenever you're dismantling a product, we should keep these things, we should pay attention to the closest, finest details. So you can see this particular IC basically has a metallic component here that contacts this, what we call as a thermal pad, and transfers the heat to the casing and uses the entire casing as a heat sink. If we did not use this, we have to put another passive fins on top of this IC. Since we already have a metallic component with a very large surface area, just by using a simple component like this, we can basically convert an otherwise member of the system that is meant only for covering the device and use it as a means of absorbing the heat from the processor and dissipate to the environment. Now let us proceed to dismantle the top portion of the case. So it basically slides out and comes out, and we have another interesting piece. So we'll cover this a little bit later. So now let us look at the DVD drive itself. So what you see is basically, now let me pull this out. So this is the loading tray, and then this is where we typically load either the CD or a DVD, the optical medium that is to be read. You load it. Once you load it and press the button in front of the device, there is a motor here. The rubber belt is missing, that basically drives the mechanism and then loads it in place. So since it is not powered, I am manually operating it. So that basically loads that pulls the optical medium into the device. Now we'll go in step by step in detail. We'll cover every part of the mechanism. So now let me proceed to dismantle the device. Okay. Now let us start with the key components of the device. The key components are as follows. So we have a central spindle that basically carries either the DVD or the CD. Now this motor is a brushless DC motor. We call this as an outrunner motor, right? There are no brushes here, so basically we call this as a brushless motor. And on top of it, we have a rubber pad that basically provides friction, because when the DVD sits on the spindle, we don't want any slippage occurring between the DVD and the spindle. So basically, just to improve the coefficient of friction, we have a slight rubber coating on top of it. And there are, I'm not sure if this is visible on the camera, there are small flexures here. I hope you can see them. So they move in and out, and they basically provide a additional centering and grip to the DVD such that it stays centered. So you have these members, flexures we call them. So basically they engage the inner outer part of the hole of the DVD, and then helps in centering as well as holding it in place. So this is, as far as spindle is concerned, these are the main functional aspects. Now let us look at the main optical drive mechanism. So basically, optical drive can, the lens can traverse back and forth to read the data which is in the shape of an Archimedean spiral. So it starts at the innermost part of the disc, and then it spirals outwards. So to read it, basically we have to think of rotating it, and then you read one long track that is in the shape of an Archimedean spiral. Now, to do that, we basically spin the disc, and then we move the lens backwards and forward. There is another motor at the bottom that helps in moving the mechanism backwards and forward. We'll look at it when we take that apart. Now let us remove the loading tray. So you can see there are no fasteners here. What I just did is, there are these two flexures that you can see, which have these projections that basically engage certain projections on the housing. So when I assemble them, it will just go, but if I pull them, it will not come out. So for us to release it, all we have to do is press it and then remove it. So pressing them basically moves them inwards and then releases them from the latch that holds them in place. Now we can get a much better look at the mechanism. Now, so this is the motor. So now we can take a much better look at the mechanism. So this is the main motor that drives the loading mechanism. So there is supposed to be a belt here. Sorry about that, it is missing. So once the motor drives it, it moves this pulley here that drives another gear here. So there is a, let me take this out. As you can see, again there are no fasteners. There is a small flexure with a snap fit here that holds the pulley in place. The pulley on the other end has a small pinion gear. So to assemble it in factory, all the workers have to do is keep it in place and then press them. There are no special tools needed. So this basically speeds up the manufacturing process and then also simplifies the mechanical design of it. So you can see in the entire mechanism, all the gears are held in place by a small snap fit flexure. So once this is powered, you can see there is a compound gear train that drives another larger gear. Basically this is to reduce the speed of the motor and basically increase the torque that is available from this small motor. So this motor can run at a very high RPM. This is a brushed motor. In contrast to this motor is a brushed motor and it gives very little torque but can run at a decent RPM. So we have this compound gear train basically to reduce the speed and basically to increase the torque that is available, because we are moving this disc back and forth, which is also carrying the optical medium. At the bottom of the tray, if you observe, you can see a rack. So basically this rack engages this large gear here, and you can see the rack does not go all the way through. It ends just before the end of the mechanism. Now there is a reason for that, I'll explain. And then if you pay careful attention, in addition to the rack, there is also a slide here, and then you can see it is sort of curved here. There is a reason for that, I'll explain. And then you can see there is another guideway here. There are two guideways. There is a guideway here, another guideway here, and then you have a rack. Now the entire thing is designed such that the person who is assembling the device is not even aware of any of this. All they have to do is they have to put the loading tray in place and then they have to push it. The mechanism self-aligns basically. Now that is the beauty of this design. Now let us look at the workings of this device. So you can see, you correct Arga. So when the motor powers it, so basically that powers this gear. This gear in turn engages the rack. So basically this is a pinion and this is a rack. So it's a rack and pinion mechanism. So basically when it runs, so basically it engages. So because this will obscure the view, I have removed it. So normally what will happen is when this gear is rotating, this will basically pull the tray inwards, all the way inwards. Once the tray reaches the end, what happens is this pinion will be disengaged from the rack. So that's why you don't have the rack all the way to the end of the tray. So once the tray reaches the end, now your pinion is disengaged from the rack, which means the tray has reached its travel limit, right? Once that is done, what will happen is you have a secondary cam mechanism, this white color mechanism that you see, that will basically engage, and so that will basically engage, and you can see basically the reading mechanism go up and down. Right? Let me do it once again. So once it reaches the mechanism, so it moves from the bottom, it moves up. Now what happens is the disc is sitting on top of this tray. Now the disc is basically lifted up from the tray. So if the disc were to rotate, it will start rubbing the tray basically. So what happens is, so once you load the disc, it's taken inwards, and from the bottom it is lifted a couple of millimeters, just 2 or 3 millimeters by the reading mechanism. You can see the entire reading mechanism is sitting on 4 what we call anti-vibration mounts. These are anti-vibration mounts. It's sitting on a rubber bushing basically. You can see I can basically move the entire mechanism. So you can see basically see the reading mechanism sits on 4 anti-vibration mounts. So when I move it, you can see it is basically suspended in space by these 4 mounting anti-vibration mounting bushes. The reason is if there are any undue vibrations from the mechanism, it should not be transferred to the case. Also, any vibration is also absorbed by the damping of the rubber bushings here, right? Now let us proceed to dismantle the device further. So all I have to do is just pull it off. So you can see now I have completely taken out the optical part of the DVD player. You can see there is another motor, third motor, that basically drives the lens back and forth. Now you can see all the cables, these are called ribbon cables. So since this has been used several times, you can see it is a bit, it has been used several times, you can see it is a bit abused. So don't worry about that. Now you can see this is similar to a lead screw mechanism. So we have a screw with a very, so we have a mechanism that basically drives the lens up and down. Now you can see the lens basically sits on two guideways. So these two rods basically enable in moving the lens back and forth in a straight line. So it moves back and forth in a straight line. Now to drive the lens back and forth, we have a third motor here that basically powers the mechanism through the use of a lead screw mechanism. You can see when the motor rotates, it can basically move the mechanism up and down. Now you can read about the way a lead screw moves the carriage. This basically follows the same principle. Also another thing to note is the lens itself, the lens mechanism itself. You can see the lens basically is sitting on a number of flexures. So if I slightly apply a small force, you can see the lens mechanism move up and down. The optical diode itself, laser diode, that basically reads is at a 90-degree angle from this axis. So it's orthogonal to it. So the reading mechanism is sitting in this axis. Now the lens is sitting in this axis. So it's orthogonal. The reason why this is sitting on a flexure is, so basically it helps in focusing the beam on the disc. So in operation, basically this uses an invisible light. Basically you have it's invisible, so we cannot see it in practice. So there are interlocks on the device that prevent you from seeing it, because it is a DVD writer. It can basically burn your retina. So as soon as you take out the electrical components from the device, so basically you cannot basically operate the device. So there are safety mechanisms in place that prevents you from running the device if you remove the casing. Now let us look at the loading of the DVD itself. Now let me put it back. So let me show you the bushing itself. So this is the bushing. You have these two grooves. So you have these two grooves that basically carry the mechanism. So you can see it is very compliant. It's very soft. So basically I am supposed to basically remove a screw at the bottom and assemble this. For lack of time I am doing this. This is not the way you should assemble it. You should basically remove this screw. This screw, basically you have to remove the screw and then put the bushing and then tighten the screw. Lack of time I am doing this, but this is not how you are supposed to assemble this. Okay, now it is in place. Again you see there are no fasteners that are required. Just by deformation, we are relying on deformation for it to assemble. Okay, now it is in place. So let me show you the loading mechanism once again. So you can see it can go up and down. Also you can see the loading mechanism go up and down. So you can see there is another cam here that basically engages this mechanism that makes it travel back and forth. Also you find another gray color component here. So this has a special application. If there is a power failure and then if you would like to take the DVD out, what you do is you take a small pin and then you press this mechanism here that basically disengages this loading spindle mechanism. So you can manually pull out the disc and then retrieve the disc. So that is the role of this lever that you see here. Now let us see the loading of the disc in action. Okay. Now what happens is this. So let me manually index it. Now I am rotating this gear, which would be normally powered by a motor. So I am manually rotating this by hand, which will normally be powered by the motor. Now before that, let me take out another important component. So this is the top part of the spindle basically. There is a metallic insert similar to the fan that we saw, fan's boss. So there is a metal plate that is embedded inside the device. It's an insert. It's magnetic. If you see, the spindle has a magnet on top of this. So if I take a metallic piece, if I put it, you can see it is sticking to it. So there is a reason for this, because if we simply let the DVD sit on it and rotate, it will not stay in place. So there is a metal piece here that basically clamps the DVD from both the ends. So let me continue with loading it. So you can see, now I am loading it. Now it is centered. Now once it is centered, you can see the spindle go up, right? Now it is not centered because I've tilted it. So what will happen is, similarly, this tray is covering from the top. So this is sitting here. So what will happen is, this will basically snap in place. Now you see the disc is centered. Now it can spin freely. So it can spin freely. It is not rubbing against any of the components of the mechanism. Once if you would like to disengage, you do the straight opposite. Remember, now see, once the magnet moves down, this loses contact. So this is basically held in place from on top part of the assembly, right, like so. So this is free to move about within this mechanism, right. Now you can basically the loading tray comes out and then you can pull out the disc. So these are the key aspects of this device. Now one thing which I would like to mention is the way the circuit board is held in place. If you look at this, right, again there are no fasteners, see. So we already saw this IC here basically contacts, so it will be like this when the device is assembled. So inside, this is how it will look, and then this basically contacts this and then transfers the waste heat that the IC generates. It's basically absorbed by the heat sink, that is the entire metal plate. Now you see the circuit board itself is not held in place by fancy fasteners. Right. So all I have to do is put this here. So there is a snap here that locates here. That's it. There is another snap here. Now it is held in place. There are no fasteners here. Okay, let us proceed to put the device back. So we take the top tray, put it together. Before that, let me assemble this back in place. So you have these, again these are metal snaps. Now basically we have a locking mechanism, and then the sticker basically prevents the user from rotating this in practice. So I had to basically cut a crease around the sticker to release the top portion of the mechanism. So you can see a simple sticker is actually functional part of the device. It's not just a sticker. The sticker also prevents this outer part of the entrapping mechanism to lock it in place. So I had to cut open the sticker to release the top part of the mechanism, to release this piece that basically holds the DVD in place. So basically I have not spoken about the ribbon cables. Basically you will have such cables here that basically will be assembled like that. So these cables basically they can flex a lot. Reason is because you have this mechanism, the optical part of the mechanism going back and forth, right? So this is missing the cable. These cables can basically bend. These are called traveling cables. So they have limited bends. So that helps in transferring the information through a flexible cable. So basically that concludes the DVD player. Let us put it back together. Right. So you proceed to fasten all 4 screws and the device is complete. To complete assembling the device, you go back and then remember these snap fits. All you have to do is first locate the top portion, locate them in place, right, and then press them in place. So there are 4 of these. So there's a snap here, 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 and on the side. Now you have an assembled piece. In addition, there is a front portion. This is a little bit difficult to remove. So all you have to do is basically in practice you just have to put a small pin. This just allows to use a small pin to eject the drive manually. Let me just take this out for a second. Okay, in practice this will basically slide in place like so. So how you will assemble is, now that I have put it, so let this stick out a bit. Okay, and then we put this. Now that completes the complete assembly of the DVD drive. Now let us look at the next product. Okay, so that concludes the disassembly and assembly of the DVD drive. I hope you found it informative. I urge you to basically, whenever you dismantle a device, basically pay close attention to the functional aspect of every single component. For instance, in this mechanism, if I have not told you, probably you may not have realized, the sticker plays a dual role. The casing plays a dual role. The casing's purpose is not only to protect the device, but also serve as a heat sink for the device. The label that is on the top of the device not only gives you the specifications of the device, but also functions sort of a fastener that holds the top portion of the lid to keep it in place. So you should always pay attention to the minute details of each and every component, because the more number of jobs that a certain component does, right, you can minimize the number of components and reduce the number of components and make it cost effective. You can see the entire device, this cost about 1000 rupees, but you saw the number of components that are there, right? This did not take place in a single day. This has been, people have been iterating it for more than 3-4 decades, and what you see is the final optimized design that you see. It's actually very difficult to optimize this any further. It's not that it's impossible, they are really well optimized if you really look at them, if you really do a functional decomposition, if you really study them. They are it's one of the most interesting devices that I have found so far. Now let us look at the next device, a digital camera, a film camera, right? Sorry, not a digital camera, a film camera, right? So you may not be familiar with this. Unfortunately, I don't have a film roll to demonstrate you. I'll just explain how it works. So basically you have a film roll, you load it in place here, and then you have to basically pull the film and basically loop it around the take up reel here. So this is a semi-automatic camera. Now let us look at the camera, right? We have the front lens, we have a viewfinder here. So this has a separate viewfinder. So this is different from your DSLR, wherein we call it, digital single lens reflex, which means whatever you see in the camera is what you see in the viewfinder. So this is different. This is an old school design wherein the viewfinder sees slightly different from what you actually capture in the device. So which means if you're photographing with this, you have to be very well aware of, there will be always a discrepancy between what you see in the viewfinder and what is photographed. So as an old school photographer, if you talk to any old school photographers, they'll tell you about that. So you have a viewfinder here that is separate from the main lens, and then you have the controls on top of the device. So this you will be familiar. You have the zoom, digital, electronic zoom. Electronic, not in electronic zoom. So basically, it is an optical zoom. It is motorized. To control it, we press these buttons to make the lens move back and forth. And then you have the flash on and off, and of course the snap button. And it also has got a recessed on-off button. If you see, look at the button layout, you can see all other buttons project out except for the power button. You will find in every camera, the on-off button will be flush with the surface. There is a reason for that. We don't want to accidentally turn on a camera when it is in the case, right? If there is any pressure on the outside case, for instance, the camera sits on this case like this. If I accidentally press, I don't want to accidentally turn on the camera when it is in the case. So I reduce those chances by making the on-off key flush with the surface. Also, I don't want to accidentally turn off the camera when I'm using it. So the user makes a conscious decision to turn the camera on and off. The user makes a conscious decision to turn the camera on off, and that is why you will find the on off button being flush with the surface of this, right? Now let us look at the film loading of this camera. So you have a rechargeable battery here that powers the device. Technically speaking, you don't even need a battery for such a camera. The reason why this camera needs a battery is you need to power the flash, and you need to power the electronics that basically drive the lens mechanism back and forth, and also the mechanism that basically winds the film. You can look at a camera called KB10. It's an old school camera. It does need a battery. You can look at a camera called KB10, a very old school Kodak camera. It uses double AA batteries just to power the flash. I've used those cameras. You can actually photograph even without the batteries. So because it is using a chemical, you expose a silver solution that is applied on a film, it works even without electricity. You can basically photograph without electricity, which is not possible with a modern day camera. Now this camera is missing many pieces, so I'll just, it's actually quite complicated. I'll just take you through an overall view of different components of it, because if it will really take me more than an hour to go through in detail of each and every aspect of it. Now we see let us start with the film loading arrangement. We'll put the film here, the canister will be here, it will be in a cylinder. You have to pull the film and then place it in the take-up reel. In this camera, the take-up reel is motorized, which means all you have to do is pull the film, keep it on here, and if you see here, there is a spring-loaded roller here. That basically makes sure that the film is pressed onto the roller when you close it. And then you have additional mechanisms in place that basically track the movement of the film inside the camera, because with every shot you have to advance the film by a certain amount to expose the next frame. So that is all automatically that takes place, right? Now let us proceed to dismantle the camera. So far we've been using larger screwdrivers. So to take this apart, you will use much smaller screwdrivers. Now these screws are very easy to lose, so we properly keep them in a ball, right? So let us proceed to remove all screws that is holding the camera in place, right? I think I've removed all of them, right? Now that removes the casing. You can see in the casing there is a provision for tripod mount. Now this is made of metal. Even though it is black, this is a metallic piece, and the entire casing is plastic. And then you can see these are rubber buttons basically that contacts the points on the circuit board to basically connect the contacts. Basically, it shorts the contacts there. That basically signals the circuit board to take appropriate action. Okay, now let me take the final screw so that I can dismantle the entire thing. Right, so just to show you, okay, you can see there are multiple motors here. You can see that there's a very large capacitor here. The reason is the battery that you have here cannot produce the necessary power to operate the flash. So what it will do is basically, once you press the button, it will charge. As soon as you start the camera, it will charge the capacitor. Once you press the, once you take a snap, it will discharge all the stored power at once to basically power the xenon flash that is there here. So xenon flashes have very limited life cycles. Typically, these bulbs last about 2000 to 1500 cycles. Typically, they have very finite life, and they produce a very strong flash. So you can see the viewfinder here, and then you can see the actual lensing mechanism. So let me take apart the show you the gear train that basically drives the take-up reel of the film. So you can see we have quite a long gear train here that basically when this gear rotates, this is connected to the motor. You can see the other gears move, and that basically engages the take-up reel, that is this black color drum here. So the arrangement is set up like this. So motor is placed all the way here. So there is a planetary gear train here. It's a very small planetary gear train. You have the output, which means I cannot back drive this mechanism, right? So this is all synchronized. If you see, if I rotate the main gear, you can see the other gears rotate also. So this is to make sure the take-up reel and the feed reel are properly synchronized. If there is a mismatch, the film will start to pull out, and it will lead to problems. So that is why you have this complicated mechanism that ensures that the take-up reel is properly powered to pull the camera and then advance the film after every photograph is taken. And also, after the film is exhausted, after you have completely made use of the entire film, you have to re-spool it back to the main cartridge. So you run the motor in reverse. So what happens is, now this drum is not powered, it has to be disengaged. So there is a toggle mechanism here. I hope you can see it. So this is automatically engaged by virtue of design. So you can see it is engaged. So now when it is engaged, now the torque on this is so high. So actually I'll risk breaking this. So just take my word for it. When it is engaged, so I can take snaps and it will advance the film and it starts loading the take-up drum or the take-up reel. After the entire film length is exhausted, the motor runs in reverse. So when it runs in reverse, this gear basically disengages, and then this can rotate freely. So you can see the take-up reel is now disengaged from the main drive motor. So the main drive motor runs in forward and reverse. So typically, if you look at such systems, they have, they are built with very fine tolerances. So when it runs in forward, it moves in increments such that it will advance the film. When it runs in reverse, it will simply drive the mechanism in reverse that basically disengages the take-up reel, which means I can basically use that as an idler wheel. Right now you can see I can rotate it by hand. You can see this gear rotate here. So now the film is re-spooled back to the main cartridge. Now you have the exposed film safely inside the cartridge, which can be sent to the lab for properly developing the film. Now a few other things to note in this are, let me put this back. So it is always a good idea to use a magnetic screwdriver. Unfortunately, I don't have one. So when handling small screws, it is a good idea to use a magnetic screwdriver. Actually, I'm having difficulty in locating the screw. There is a separate motor within the casing. It will take a much longer time if we start dismantling it. It is actually inside this that basically drives the lens mechanism, the zoom mechanism back and forth. And other things to keep in mind are these LDR, light dependent resistor, that you see here, because back in the day you have little control over the ISO, what we call the ISO. These days digital cameras, you can take your smartphone for instance, you can change your ISO, put it anywhere from 0 to 1000 to 12,500. Even expensive cameras can go as high as 25,000, which means basically it talks about the sensitivity of the sensor. Back in the day, you bought films that are rated for a particular ISO, which means if I buy a 400 ISO film, I'm stuck to that, right? Yeah. See, which means if I buy a 400 ISO film, I'm stuck to that. So you also have this LDR basically. So what is the role of this LDR? For instance, if I'm shooting in very strong daylight, there is no need to basically power the xenon flash. So the LDR basically measures the light intensity outside the the environment, and then basically it will basically turn off the xenon flash from operating. If I'm shooting in a dark environment, basically I can measure the light intensity with the help of the LDR, and then I can turn on the flash if necessary, right? So that is something to some key details to remember. Another thing is, when you are photographing with this camera, basically you have very limited number of exposures, typically around 35 to 36 exposures, even lower. So basically you have to plan ahead before you take any photographs. So those are some of the key details of a old school film, semi-automatic film camera. I hope you found it interesting. Now let us put it back together. Okay, all we have to do now is put the screws back to complete the assembly. So a proper way to operate this is what we call as a watchmaker screwdriver, is to keep your index finger on top of this and then use your middle finger and index finger to rotate. So whenever you are turning a screw, please don't do like this, so you won't have good control, because when you're handling a very fine screws, the way you use them is you apply a slight axial load, right? Keep your index finger on this, so it has a freely rolling surface. So what you do is you keep your index finger on top of it and then use your if needed, you can also use your ring finger, use your middle and use your thumb, middle finger and ring finger to basically apply a torque on the screwdriver while also applying a slight axial load. You don't go around turning like this, that basically you will end up damaging the head of the screw. Also you'll end up hurting yourself. If this pokes into your hand, it's pretty dangerous. Despite its size, it's quite dangerous. So the way you properly do it is, first keep the screw properly in its place, locate it. When you do this, you also have good control. So okay, let me take another hole. Yeah, so you keep it there. So you locate it and then you start rotating. See, now it's properly assembled. So you do that for every screw. So that is the key difference between a watchmaker screw and your normal screwdriver. This is a much more precision device and you have to have proper technique for using it. Okay, that completes the assembly of the camera. I hope you found it interesting. I urge you to go through Wikipedia's page and explore different designs, the evolution of camera itself. I'm sure you found this quite interesting compared to your normal digital cameras these days, because you need to have a lot of electromechanical devices here, right, to basically okay. So I'm sure you might have found this the mechatronic arrangements quite interesting when compared to pure digital system that we have these days. Even though the photographic quality of the system we have is far superior to these systems, back in the day they were quite a marvel to hold. Even today, I mean, I'm sure you will find them quite from an engineering standpoint, they are quite interesting to observe. From a product design standpoint, you can really learn a lot by exploring the finer details of these mechanisms. I actually did not do justice to this device. There is a lot more to this device than what I told you, but I'm hopeful that I have just piqued an interest for you to explore old devices on your own, and then get to understand from a functional, from a design standpoint, and basically get into the designer's head, and then basically explore the thought process of a designer as to how to go about designing such a device. Thank you.